All right, so the end point is the point where the titration, what did I just do with that? Where the titration is all over. So you're adding your base to your acid, turns light pink for a little bit, goes away, it's pretty close to 7. All right, but that's just for phenolphthalein. That's the one that we use all the time, okay? You can do titrations with other indicators, okay? So go to table M. Can I erase this?
Wait, what's the Joe mole? That
So.
didn't help.
Yes, it doesn't help.
It's an S. That doesn't look like an S to you?
No.
How about that?
No.
That's an S.
That's-
Wait,
you know, that's good
Can you
enough.
draw 5? How do you draw 5?
I don't do the same thing.
I don't know, I'm just saying.
Well, I don't even care about that word. This is what you need to understand. So when that's light pink for a little bit and then goes away, your moles of acid should equal moles of base, which is why it's about a pH of 7. That's the normal thing you need to remember. But you can do this with a different indicator. So go to table M. If I wanted an endpoint that was not a pH of 7, so I'm just going to add this here to our notes. So if we want an endpoint around, let me get my table M out, 4, what indicator should we use? Methyl orange. We would use methyl orange. And the reason for that is because it's 3.1 to 4.4, right? Yeah. So that's where the color will change. So again, this is kind of a little extra. I don't think this is too common on the Regents, but if it's not phenolphthalein and it's something else, then the pH change, the pH where it turns color, the endpoint, is going to be different. Okay, so if you want to do a titration with a different endpoint, you have to use a different indicator. That's another use for table M, besides identifying acids and bases. All right? And I'm going to draw a picture of a titration curve because you definitely should at least see it. It was on your homework that was due last week, but I'm going to draw one in our notes, go over some properties quick, and that's going to be it. Okay, so a titration curve. So set up a little axes in your notes. It doesn't have to be super big, but big enough to label some things. Okay, and it kind of looks like an S actually. Speaking of S's, so it's going to kind of look like this. That's a titration curve. Down here is volume of NaOH. Over here is going to be pH. So remember, you have your acid down here and you have your burette up here. And this has your base in it. You don't have to draw this picture here. Just trying to get you to understand. So let's say the pH of this acid starts out with no base. I have not opened the valve, I have not dripped base yet. Let's say the pH is 2. As we add base to this, let's say right here at this point, we add 25. All right, let's say it's milliliters. So we add 25 milliliters, right where it's vertical. Right here, let's say, that's about 7. That's our endpoint. That's where the light pink color would be for phenolphthalein. Then if we keep adding more base, the pH rises because you're adding more and more base. It gets dark pink. So up here would be our dark pink color, okay? And let's say that pH here is like a 12. So then if I extend this, let's say, you know, we add, I don't know, whatever you think that would be. Let's just say 50 milliliters. I know it's not perfectly spaced then. But that's what a titration curve is. My hope is when you do the lab, we're going to use the iPads, it's going to be graphing while you're doing your titration. Hopefully yours kind of looks like this. You'll see it goes up gradually, then it sharply goes up, and then it levels off a bit here. So this is your endpoint. And again, you should have a concept of what a titration curve looks like. So as you add more base, the pH is going to go up. That should make sense to you. So if you add a certain amount, it's neutral. You add too much, you go way past the endpoint, it gets too dark, that's too much base. All right, so that was just one more thing I wanted to throw in there. But again, our lab, we're gonna do that. Questions on that? Okay, last thing. Properties of acids and bases, and we'll get out of here. All right, so properties, and then we'll just put acids over here, and then we'll put base over here. There's just a few things. We've already kind of learned it all. We're just going to put it in a list. Both of them are electrolytes. What's that mean? Both are electrolytes. They conduct electricity in water. Why? Because they have ions. H plus ions, OH minus ions. Anything that produces ions in solution conducts electricity. Acids and bases conduct. Both of them are corrosive. Both are corrosive. They'll eat your skin right off your body. That's why you have to let the soap sit for so long. The shock test, you can lick it, I suppose. Acids tend to be sour. Bases tend to be bitter. I can't think of something that's basic. I want to say some sort of vegetables, maybe like spinach. It's kind of bitter, I feel like. I think spinach is maybe a little basic if you were to like smash it up and try and get it to dissolve in some water. I feel like it. I could be completely wrong. I don't know. But some foods that are bitter probably are a little basic. Think of any fruit, especially ones that are citrus.
Orange.
Right, orange, lemon, lime. They're acidic, they're sour. Okay, orange juice. Let's see, what else? Oh, bases are slippery. That's part of why soap is slippery. Part. The glycerin that she was talking about, that's another reason why it's slippery. But bases are, so if you spill base on your hand before you wash it off immediately, it's a little slippery. That didn't make any sense if you think about it. Before you wash it off immediately. All right. And one more thing I'm going to put here. Acids react with metals very easily, more so than bases. They react with metals to produce H2 gas. That's not, crucial if you memorize that or not, but acids will react with metals a little bit easier than bases will. Okay, that part of that corrosive thing. There's other things, but I don't need to make the list go on and on and on. You need to know acids have low pH, bases have high pH. You know that. You need to know what color the indicators turn for acids and bases. You know that. We already went over all that. These are just some general, kind of more real life type things people need to know about acids and bases. All right. What's inside batteries? Battery acid. If acids didn't conduct electricity, then it wouldn't be used in batteries. That's just an example for you. Okay. All right, that's it. We are done. Bell's gonna ring here in a minute. So do that worksheet due tomorrow, and tomorrow we start redox, electrochemistry. Be excited. It'll be electric. All right. Electrochem is electric. It's exciting.
I've touched battery acid before.
You've touched it.
Dylan Miller and I
How'd
was
that work out
smashing
for
some
you?
batteries.